All right, so it is easier for proportions, confidence intervals, because there are things that we have decisions to make for means that are not an option with proportions. So just thinking through really quick with four-step process for means in plan, the very first part of plan is what? What's the very first part of plan? What?
Confidence.
Choosing your method. So what's our decision there when we're dealing with means? I have to decide if it's what or what. We don't have to make that decision with proportions. It's always going to be z. And then when we get to normal for means, how many options do we have? How many options do we have to check for normality for means? 3. Easy. What's an easy one? It's given. What's another easy one? Central limit theorem. Or we get to the point where we histogram. So when we get to, so here it's always going to be z. How do we check for normality for proportions? What do we have in proportions? So some form of this, both of them being greater than or equal to 10. So again, we don't have the decision with normal, we don't have the decision with method, so it makes proportion stuff a lot easier. So I'm getting ready to rewrite all that, but it's kind of easy to, it's nice to see side by side what changes. All right, so the first bullet point on there is the first thing I talked about with we never use t for proportions. Can you think of why we don't use t for proportions? So back up and think, when do we use t? And so we do have what instead? What do we use instead of sigma? What letter? S. Do we have that if we're dealing with proportions? We don't have a standard deviation like S or sigma, so we're not dealing with that. The other thing is, and this is what I very quickly brushed over before I gave you a chance to think about it. We are estimating P so P is what we're trying to find the interval for. So where do you think this could end up being an issue? Or why do you think this could end up being an issue? If we're trying to check it and we don't know what it is to plug in there, we can't use it. So we only know what? We don't know this, but we do know yeah. Which means, would it be better to use the one for the population or the one for your standard or for your sample? In all scenarios, would it be better to use the correct one for the population or the estimated one from your sample? The population one. But, so if we have them both, we use the one population. If we don't have them both, we then result with using the estimated one. So that just means instead of doing n times p and n times 1 minus p, we're on n times p hat and 1 minus p hat. So our formula for confidence interval. So when we were dealing with confidence interval for means, this was our x bar plus or minus either z times sigma over square root n or x bar plus or minus t s over square root n. Well, now we don't have x bar as our point estimate. We have what is our point estimate? P hat. But we're still going to have plus minus. here I had the option of Z and T, but we know now that we don't use T, so that has to be
Z.
Z. And here, these were both trying to find standard deviation of our population. So what is standard deviation when we're dealing with proportions? This is sigma of X bar. So what is sigma of P hat? All right, so now, do we have P to use? So we have to use what instead? P hat. But that does come up later where we have both. So you always want to use the one from the population unless you aren't given it. And then you have to go backwards to using the estimated one. So just kind of checking our vocab stuff here. What part of that is margin of error? And what part of that is standard error? And from before, we called it standard. What was standard error with me? So the top one, or right here, if it was at home, was it the top one or the bottom one? Which one of these is standard error, the top one or the bottom one? Why? We had to estimate that with a statistic. So it's not our standard deviation, it's our standard error, because we had to estimate, well, P hat, we didn't know our P, so we had to use P hat estimated in there, so that's our standard error. All right, so this A and B problem, I'm gonna go through and kind of quickish. All it is saying, check whether the conditions have been met. So I'm gonna have more space than you do. First condition is random. An AP statistics class in large high school conducts a survey. They ask the first 100 students to arrive at a school one morning whether or not they've slept at least 8 hours the night before. Only 17 students say yes. So random, yes or no? Random, yes or no? Not a hard question. Random, yes or no?
No.
Now, if I were asking you, could you continue? You could technically say no, but obviously I want you to check all these here. Going back to chapter 4, what's it? If I just ask the first 100, what kind of sample could you say that is? It's definitely biased. What's a specific type of sample? This is a kind of a generic one. What? It is biased, but what type of sample? Why did they just pick the first 100?
Convenience.
Because it's convenience sample. And why is that? Because you said it's biased. The first ones who get there are going to be different than the rest of them. All right, so our second condition is normal. So what would I be checking for here? We would have to be checking for this. Now, because we're doing it for the sample, this often gets really easy. and I usually don't do as much math here. In general, what does N times P hat mean? This is my number of what? Successes. So what does N times P hat answer here? What does N times P hat give me in this problem? Exact number. How many successes were in this problem? And so it kind of makes it easier on you because of that. Now, technically, P hat is 17 out of 100. N is 100. But it told me how many successes there were. So that means how many are left for failures? Because it told me the 17, so 83 is what's left over. And then I would continue on to say there are at least and students who, I guess I would check. I'm more concerned with continuing on. Let's just say there are at least 10 ... You need to write that out, but I don't want to spend time writing that out right now. So we can, we'll put so we can ... Independent is checking what? So that's not going to change at all, which is capital N is greater than or equal to 10 lowercase n. I have lowercase n, which is 100. And we would have to say there are at least 1,000 what?
Students at school.
And I would just say students at this large high school. All right, so I'm going to go through B without writing it because I don't want to get into this where it looks like you're okay with not writing it out. So we'll just have the conversation instead. So for part B, quality control inspector takes a random sample of 25 bags of potato chips from thousands of bags filled in an hour. Of the bags selected, 3 had too much salt. Random, yes or no?
Yeah.
Yes, random sample, which is random selection. Normal, yes or no? So thinking through this, our N times P hat would give us what? Which is what number? 3. Is 3 at least 10? No. So we're considering success here being too much salt. 3 successes and 22 failures. 3 is not at least 10, so it would not meet that normal criteria there. But I can continue to say independent. 25 times 10 is 250. This is kind of one of those assumed things, assuming that what? It does, it says, I don't have to say assuming because of why. It says that thousands of bags are filled in an hour, so 250 is less than thousands. So it would meet the independent criteria. Are we good with those without like writing all those out? Okay, good. So let's go ahead and go straight into a 4th step. And again, like I said, this just continues with what we've been doing. If I could pretty much, after what we just went over, I could pretty much hand this to you and you can fill out the whole thing without me saying anything, hopefully. But we just kind of have to make sure that we're all on the same point with like which words change, which words stay the same, that type of thing.
That's it.